right. Well, folks, thanks for the opportunity. Unfortunately, I couldn't be there in person. It's a bit of a long flight from Brazil to Sweden. So I'll be doing the boring part. You guys are enjoying the fun part of having the breaks and the evening beers and so on. But yeah, here we go. I'll be talking about KernelCI, and the goal here is to, of course, like share with you a little bit what's going on in the project, but also together with Luigi, we want to discuss a little bit like the possible integrations we are envisioning with KernelCI. There is, of course, a million of things for us to discuss about kernel testing and functional safety, how we can do that in a CI environment that pulls the entire kernel ecosystem together to work with maintainers of the different companies and so on. And those are all the different things that KernelCI is trying to do lately. A little bit about myself, being in the kernel community for a while as a kernel developer, not so much these days. I got a little bit bored with C programming for some time, so I've been flying around with other things. Nowadays, I'm part of KernelCI. I'm one of the board members, but also the main person behind like all the growth that you've been seeing from the project, like in the past 2 years or so. And I've been with Collabora on the Linux kernel side of things, driving business there for 13 years now. So the main thing that we would like to talk about when we present KernelCI to people is it's not just CI, right? We live in this pretty complex community that has been around for 34 years already. And there's a lot of ways that we work or toolings that we have, behaviors that we have that are not really prone for testing or CI integration and so on. So we've been really putting up this as part of our mission that we need to help the community have some sort of cultural shift as well. It's not going to happen if we create the best CI system and we leave it there and ask people to use it. We have to work with the community. We have to understand all the different use cases. We have to support a moving different process that we see today in the kernel community, one by one, step by step. I think KernelCI is like the kernel, right? It's a long-term mission, and we've been trying this one for a few years already. And in terms of goals, KernelCI as a Lund Sweden project and a sort of a sister project to ELISA in this regard, our main goal is to ensure the kernel quality, stability, and the long-term maintenance. As part of that, we've been working a lot to consolidate a bunch of different strategies and stories around the community, and trying to build something that's going to be supporting an entire ecosystem of testing. Because if you look around, you see many people doing kernel testing in many different ways. I think one thing that's pretty clear is that we are duplicating a hell of a lot of work in kernel testing, but that doesn't mean that we are testing everything that need to test. That doesn't mean that those results are getting to the hands of people who needs to look at them. That doesn't mean that we stopped having regressions that are hurting systems in the field or preventing us to go into more safety scenarios. So there is a lot to do there for KernelCI. We want to be an umbrella for different projects who are working with kernel testing. And we've been setting up our working groups. We also want to be the place where standards are created in terms of a kernel testing. I'll be talking a little bit more about all those things, of course. And there is also the organization side of things. Because we are a left project, we can take more responsibility and accountability on things. So KernelCI manages a lot of a software infrastructure deployments and the cloud credits and so on. So we take some of the complex out of the community. and of course we have like some budget from our members, and then we can also sponsor some initiatives. So that's a broader review of what KernelCI is trying to achieve today. On the left side, our project, those are our current members. ELISA joined us recently as associate members, and we joined ELISA recently. That was pretty cool. We're about to announce 2 new premium members, billion-dollar companies, but I can't really say their names yet, but they should be showing up soon in our premier members listing. And this guy here, I think you know him. He has been our ambassador from day one, from helping set up KernelCI under the Lund Foundation, and always prompt to support us or find new members or test things that we are doing and so on. So this has been like our ambassador in this journey, and that's my moment in the talk where I'll do the pitch for people to become members of the KernelCI project. I see a lot of alignment between the things that we are doing in ELISA and what we are doing in KernelCI. So if you have interest, of course, we would love to see more companies joining. I had a slide somewhere with fees and so on, but that's not that important. Okay, so if you have questions at any moment, maybe we can go and answer them. Like people in the room, if you can help me with that. But I'll be going with the presentation. But feel free to stop me anytime that you feel like you want to discuss something or ask something. This is to be a discussion and not me talking for half an hour straight. So that's our a highlight of the audience we are trying to work with, right? It's not a surprise. Like we want people who are maintainers of the kernel. We want to see upstream developers. We want to see hardware vendors. We want to see product makers. Out of those people, they have a bunch of needs when it comes like to ensuring the quality of the kernel, testing, validation, and so on. And many of those folks, they have something that they're doing already, like the number of private dashboards I've been looking at in the past year that like this company has, that other company has, and no one talks to each other. It's just like, it's crazy. So everyone has something to do with kernel testing. And then KernelCI is, of course, like providing ways for people to request testing, to add or improve like the tests that they're running in KernelCI. And then evaluating the test result as well is one of the most important parts of this endeavor. There is this like the kernel community audience. We would have once I move to talk about the technical architecture. There will be like other groups of folks that will benefit from connecting to KernelCI. So essentially, if you see my mouse pointer, like the audience that I was showing up kind of like sits in here. I won't go into much detail about this, but essentially we have a core orchestrator that's called Maestro, where we start a bunch of test specs, we build the artifacts with file seeds and so on. And it kind of like behaves as an event bus. Where different systems can plug themselves to it. But the gist is, yes. Is someone asking to me? Okay. No. So the gist of it is that like different systems can send requests into the KernelCI ecosystem through Maestro. We have, of course, support for watching ditch trees. We've been working on some GitLab solution, which is not yet where we want it to be. We have an integration for those who are familiar with what the NetDev BPF subsystem is doing. So they're able to throw test requests to us to execute hardware specific tests, which can then land into one of the labs attached to KernelCI, or into any of the CI systems that are listening to the events that are generated here. It's not mandatory, of course. People can have their own systems and submit their results to a common database. So those, like under the hood, those are the two main pieces. We have a core orchestrator, a common database. Users would be here on top requesting things or just pushing stuff to their tree. There's a tooling that you can use to see results or to ask for test requests. It's something that it's pretty new. We're evolving it. Like, it has a few months old. The app dashboard is also pretty new, but it's quite used for a bunch of use cases. But we're actively developing it. So this is like the layer where the community access it. The CI ecosystem is, of course, like a pretty important piece as well, where we can bring anyone in the industry who is doing some sort of kernel testing to contribute their test results to us. And that's the case for those companies. In the past few weeks, we've added to, I think I need to update this box, but the Texas Instrument is now here. RISC-V International is also part of this. And those Qualcomm as well have their lab. So there's a few new members here. And those new members, they're also listening to events here. So one of the visions we have is, I'm a maintainer or a developer, and I want to get like something tested in this specific device because, well, there was a regression. I need to try out like a patch on top of it. And if I go through KCI Dev, I get like the proper security, like token authentication and so on, to be able to send a request to a device into the ecosystem. I send it here, and then this orchestrator is able to generate the events that the right place will pick up. There is the labs where we connect, especially Lava Labs, for those who are familiar with the Linaro automation tool for devices. We can connect like a multiple labs. Collabora has one, Believe has a lab, CIP has a lab. There's like 5, or Qualcomm has another lab into there. So the labs are kind of like an integral part of Maestro nowadays. But it's one of the places where we look for a different type of audience, right? We want the people who wants to bring their devices to be tested in, and then we have like this infrastructure for them to either connect themselves as a lab or to set up whatever system they have, write some wrappers here to listen to events. Those folks here, what they benefit from is like with cases like the one I mentioned, where a maintainer wants to do some extra testing, or just like being there passively receiving any new test request that's coming to KernelCI. Like, let's say that the PCI tree was not being tested, and then we add that tree, and automatically systems can just pick up that when Maestro start like adding those tests. And of course, like you can benefit from the kernels that are built, so you just need to download the artifacts. The root file system are there as well. So that's pretty useful for the ARM ecosystem, for example, today, because they see all those like artifacts available in KernelCI, so they just pull them, run it inside their firewalls because they have limitations with their IT infrastructure, and then they send results back into KCIDB. And then we process them. We have ways to analyze the logs, extract some intelligence, something that we believe is going to grow a lot over the years, like this intelligence layer on top of the data that we have, because it's too much data. You can imagine that. So that's that. One thing that's missing here is a storage server, because we need to store logs and other things. And we recently deployed one, but I forgot to update this drawing. But we have a service for storing like files in a more medium-term manner, so we can see the logs like for a bunch of months in there. All right, so that's the gist of it. Any questions so far? Is this
as we get requirements hooking up to the Linux kernel? How do you see that playing in here?
Yeah, so I have something that let me there is something that I'll share in a bit, which is one of the next few slides. It might be part of might be interesting proposal for requirements. Let me get there. Oh, that's the slide about the membership level was different order. Anyway, if your company is interested, like we are happy to talk to you. Okay, current community work. One of the main things there are many things we're doing right now, but a big one is the web dashboard, which I can screen share the right tab here. So that's our dashboard. You can navigate through a bunch of different trees, like mainline. You can see it's a lot of data, so our database is still going through some optimization. So you will see some of this is low load sometimes, but then we can see our build results for the most recent checkout. This is bringing up like a graph of what has been happening on the device. We can filter by like the different architectures, for example, and down here you can look into all the different results. That's the same for boots. Look into all the different hardware that is in build, that you've seen boots. You can then go and see some of those results. Sorry about that. The log's not available for this one. I think that's the demo failing right in front of you. But we have a lot of interesting thing. I won't be, I know, giving you like a lot of demos here because I don't have that much time. But one of the interesting things that we have, let me share this other tab instead, is that as part of the infrastructure, we are able to capture issues that are happening, like kernel crashes, oops, and things like that. And then we can make them come to the surface, like this one, for example, where you can generate a report to the community with that specific information. Like this thing, for example, it's a different report. This is for build failure, but it's something that we've been putting together in the past few months in the new KernelCI infrastructure. Yeah, one piece of context, by the way, is that last year we moved on from legacy KernelCI to the new infra. So a lot of things are still shaping up because it took us a while to get rid of something that was pretty old and legacy and giving us a lot of headaches. So a lot of those things I'm telling you here is like stuff that we've been building for, let's say, 6 months, 12 months. So there's a lot of work to do on those. Let me go back to the presentation. Oh yeah, I showed you example of regression, but we also have the status emails reports, which is this one. It's something that we are growing, but we are able to generate like for each Git checkout that we test reports where we can separate like the possible regressions, and then people can just click here and they go direct to the dashboard and they see the results in there. We're also flagging some of the fixed regressions, and then there is this category here where we need to dive deeper to understand like the different patterns that may show up in here. But sometimes there's like infrastructure errors, or the CI system just like eats up some data, and then we are not able to figure out what's going on in most cases. That's one of the main challenges for KernelCI is the noise ratio level of things, because we're dealing with a lot of hardware and we're dealing with like different CI systems, so we end up like being unable to have clear data for everything. We've been focusing a lot on the builds and the boots because those are easier to work with, and it's like a reduced set to spend time cleaning up like the whole feedback loop from executing the test to landing that into the database to showing that to the dashboard and to send notifications to get the maintainer to see it and fix something. So we've been trying to clean up a lot like that build and boot process, and of course everything else is available, but and the community is looking to some of those other results. But as a community right now, we're trying to clean up like our main step of improving the quality of the data, like the build and boot results. All right, let me go back to this. And the dashboard is something that the KernelCI is sponsoring for our fundings in there. Next thing is KCI Dev, which is a pretty interesting tooling. Still early days. We start writing this in December, but I'll leave the link here for you folks. We can try jobs, we can view results from the dashboard, and that allows people to start like scripting things around KernelCI. We envision a lot of use cases for this, but as I said, it's a tool that it is quite young. I'll let you play with the tooling if you want. KCI.dev is our website for the tooling documentation. And moving on. So the KernelCI YAML file, I think that's where I try to bring something for discussions of test requirements. We've been brainstorming like a bunch of things around how do I get like a maintainer to actually contribute what they want to test to be tested for this system, or for different groups of people to specify like the test plan for the user case. And I was like, well, what if KernelCI starts to behave more like GitLab CI or Drone.io or some other CI environment that we are familiar. And we've been thinking of this .kernelci YAML file that maintainers would add into their folder, the folder they maintain into the repository. And that file will start slowly to grow into a sort of like a test plan that will contain everything that we need for executing tests in that subsystem. I don't know what everything means because we need to discuss every bit of that. We spoke to a few maintainers. They are extremely happy with this proposal, because nowadays what happens is that you have to go to KernelCI Git hub organization, you have to clone a repository in there, and then you have to edit like a bunch of YAML files that you don't really understand. And then you have to submit a pull request. Your PR might be broken because the YAML is pretty complex. So it's not really easy. So it's like, what if we create like a YAML file where I can say, look, that's this and this branch. Can you do this and that architecture? And then all those kernel configs. And then I'm interested in these LTP tests here. And then I think it can evolve, right? I'm interested like in this piece of hardware or this family of CPUs and so on. And then it can go even further than that to like the DRMCI, the DRM system with DRMCI inside the kernel. They are storing their own test expectations, like the pass expectation, fake expectation, flakiness. They are storing all that in tree. And then if you have something like that, it's just like a matter for when we are pulling a tree, we read that file. We have to know, of course, a match between the tree and the YAML file for that version tree inside the tree, because there will be like dozens of them, but that we can solve. And then the CI system will just like be able to test whatever the maintainer needs to, or you can supply your own YAML file for some specific test that you may need. So that's one of the things that we are starting to work right now. We are doing some refactoring first on the KernelCI side. And then later we will probably work with a few maintainers who are pretty much happy with this idea to just push this file through their trees. And I think then the work starts to discuss with the community how this standard is going to evolve and so on. But that's essentially something that might have a good relationship with test requirements in the future.
Yeah, I think that's probably. So do you have the syntax of the KernelCI.yaml file and which field specifically all mapped out, or is that still flexible?
It's still flexible. So right now we're just moving to that file the things that we actually allow people to configure in KernelCI, which is and we're focusing on builds, of course, as a start. So right now it's only the architecture and the branch, and very soon we can do the kernel configs, and then at some point we can do the hardware or the tests. The biggest problem is that the KernelCI, the current KernelCI configuration is exactly our legacy configuration. We had to just carry that over all the YAML files, and it's like a mess. Like really, you don't want to see it. Like, and we are trying to clean that up. And I think that.
Well, what I'm sort of interested in is the concepts behind in there, so that we can make sure we have fields that match some of the stuff we're lining up for hooking up.
Yes, I mean that's why I think we need to bring this to the community as a discussion, right? I think if it is for KernelCI to be the first to implement it, I think we need to move in sync with what the KernelCI team is able to add to the system in terms of like reading that file and making sure that we can actually do the things that are written in the file in terms of like filtering, because that's our main challenge right now. To move away from our current system of configuration to this, it's going to take a lot of work.
Yeah, I gotcha. I'm just thinking that if we can do the work smartly, we should be able to map it into SPDX. And then we can hook it in with other systems down the road with the SPDX fields that we're trying to catch for this type of linkage. And then some of the requirements, traceability stuff should plug in fairly well. Even if you've got the YAML file in different terms, we should be able to have a one-to-one map with what the fields are in SPDX. It's kind of what I'm hoping for here. Okay.
Yes,
so I'd like
that
to
makes
be
sense.
To start to explore it, the file, and what you sort of see as the rough syntax in the file, or the syntax you're aiming towards in the file, and then do a little bit of a thought experiment, side by side, and see where we have any gaps or not.
Yeah, and one thing I see is that this will probably evolve as the .kernelCI folder, because there's like so much data at some point, like expectations files and the configuration and the requirements, SPDX, this and that. There's a lot of room for growth in here.
Okay, so I think next steps then are probably to take, and if you can share some sample KernelCI files, YAML files that you think are good indicators, we can try to start matching it up on the SPDX side, and then looking at what has to happen, what the gaps are in the format to support that, if any, and then also figuring out how it's going to hook in with what Luigi's able to export out of BASIL for the requirements, and how we might be able to start augmenting it for more than just manual from the analysis.
That makes sense. Yeah, the other thing we're trying to do is to get these truth maintainers into the mainline.
Oh yeah, we're trying for that too.
Yeah, so that's like that's why like we are really pushing this idea, because maintainers love this. Like they're really behind. Some maintainers, of course.
That's good. Are you guys going to be trying to do a mini conf at Plumbers on this topic?
We can do. Yeah, well, we can do. Yeah, for sure.
Because we're probably going to try to do a mini conf on safe usage again, and do some of the work for the templating requirements stuff that we've been working on, and following up from last year. So we basically try to do the testing, mini conf, and the requirements, make sure that they don't happen at the same time, for one thing.
Yeah.
And then try to get the discussions with the kernel people there going in both.
Yeah, this is a pretty good talk for Plumbers. Yeah, and we'll probably be discussing that like in next month in Denver. We have the Automate Testing Summit as well, so this will probably be a discussion there with people. That will be on the 26th of June, co-located with OSS North America, if anyone is interested on that.
Yeah, I'll likely be there. I'm trying to get into it.
Nice.
Got another use case for this. I think as the kernel maybe has more white box testing, this might be an interesting way to actually drop in and test subsections of the kernel or I guess it eliminates some of the obscurity of where the tests are all located in one spot and the relationship to the other content, especially when you have a lot more test cases. Maybe like you have a bunch of K-unit user space driven tests that really go in and mock out code. Having this right there with it, I can see could simplify just that picture of how you're doing testing kind of requirements at that finer level.
Yeah, for sure. Yeah, and the other thing is, right now we're testing, funnily enough, KernelCI is testing too much for a bunch of subsystems because we just don't know what to test. So we enable like a bunch of things, which in turns become noise for the community and those who are looking into the tests. So having this is going to clean up things, because sometimes, yeah, I need this and that config, and then I need those 5 tests. That's like might be enough for some maintainer out there. But we are doing like 100.
One of the subsystems that might be interesting to explore is the real time, because they've been doing a lot of work, obviously, on their testing. I know Thomas.
Yeah, they are the list of people we spoke with. Yeah, they're loving this.
Good.
Any more comments on this?
I have one question.
Yeah.
So I tried KernelCI our on place. So my understanding of current KernelCI depends on Google Cloud, is correct?
The infrastructure is running Google Cloud. That's your question?
Yes.
Yes.
Most of it is running on Azure. The last piece that we have on Google Cloud is moving away soon, because we found ways to decouple it from Google Cloud proprietary technology that we are running for KCIDB. So that's the database itself are deployed in Azure, but we're still proxying things from the old interface to the new one. But most of it is Azure from partnership we have with Microsoft at the moment. But it's all deployable anywhere. It's like just Docker containers that you can put anywhere, including internally in your company, which is a use case many people has been raising up to us, that they want to run certain parts of KernelCI internally because of embargoed hardware or embargoed like kernel code and things like that.
So do you have any plan to these topics?
I mean, we have a bunch of ideas. We need more contributors, essentially, or people to sponsor those. Yeah, that's classic problem.
So I have many time to talk to Greg. So KernelCI is a very helpful to kernel community side. So I think this opinion, same opinion, but KernelCI, some hardware have includes NDA-based information.
Mm-hmm.
So in this case, we have very difficult using the KernelCI public.
Yeah, so that's why it's open source. You can put it in your own organization, right, Gustavo?
Yeah, like I think we need to take a few more steps technically to prepare the systems for being deployed internally, but it's totally doable. Yeah, and that, like, many companies have been talking to us about that. Like, look, we want to just run this internally for things we can't really share. And like the dream is that if people do that, maybe they'll also be doing something that's public, and we can have something that like can take decisions. Oh, this is embargoed, keep internal. This is public, send it upstream KernelCI. So you can like really be connected to the main KernelCI, but just running on open source. But that's like a little bit of a thing right now.
Thank you.
Any other
Okay, let me see
questions?
if
Anything in the chat?
Then we move over to Luigi. The second part of this presentation.
What? Yeah, thank you so much, Gustavo, for joining us.
You're
Hopefully
welcome.
we'll be able to get a pleasure in person again sometime soon.
Yeah, endeavor. Yeah.
I'll see you in Denver. A lot of the others will be in Europe if you end up coming over to OSSU in August.
Yeah, I'm not sure if I'm counted one up in the US, I think.
Yeah, okay.
Oh yeah, thank you folks. It was a pretty good opportunity. Yeah, I would stick around and be part of the BASIL discussion as well.
Hello, everyone again. My name is Luigi. I'm principal software quality engineer at Red Hat. I want to start.
Oh, just a second, I'm gonna stop the other one and start a new one. Oh, it's all one, that's true, that's right, never mind. Okay.
Yeah, okay. Yeah, so this talk is about BASIL. It is a tool that we are developing in ELISA. So it's kind of update on the development of this tool. So we will see. So I will go through an introduction because there are many people that see it for the first time. Then we will see some features that we developed in the last few months, at least from last workshop that we had in December. And then I will try to go very fast on those things, and then I'll try to have some time for a demo, for a live demo. Okay. So this tool has been created to create and maintain software-related work items and to design the traceability matrix of those work items. And it's born at Red Hat, trying to help us in our work with Rivals, our distribution for automotive, and to comply with the safety standard for automotive. And its name comes from the integrity level that we want to achieve. So ACBN becomes easily BASIL. And it was presented to ELISA during one workshop like this one in 2023, and then we quickly upstreamed into the ELISA GitHub. So this is the link to the repository. You can go on it and have a try with it. So that's an introduction to explain how this tool works. Essentially, you can, working on a software component that you can organize in libraries, you can, the first thing that you have to do with this tool is to specify a reference document. That can be a software specification, can be your source code or any kind of manual or any other document that makes sense for your project to develop the traceability on top of it. Once you specify it, you can split this document in snippets, and to each snippet you can specify the set of work items with the hierarchy that you want. This picture is a bit small, so I have an exploded view where it's more clear that for each snippet you can specify a hierarchy of software requirements. You can specify test specification that can be also mapped to requirements, test cases that can be mapped to test specification or software requirements, or directly to the reference document. Then we have another work item that is justification that is used to help to achieve a completeness of analysis. So you can have in your specification pieces that are not relevant to the analysis that you are doing for this software component. So you can use this work item to clarify those things. And there is another work items that is a general purpose document that has been created to let's say, to use all the possible relationship defined in SPDX, so you can create the relationship between any kind of files that can be, for example, a data set that you use to train an AI model, or requirements itself, or a test case itself, but any kind of document that can be used for your traceability. Here you see also test results, because this tool comes with an embedded test infrastructure that is quite powerful. Has been developed on top of a tool that we have at Red Hat that is TMT, is developed. test management tool. Is kind of an abstraction layer that we have on top of test cases. So with this project, you can abstract your testing. So and you are able to run any kind of test suite against different kind of system test environment. That can be container, virtual machine, physical hardware, and whatever. It's not only that, because the test infrastructure is not only the embedded one, but it's also BASIL. During last workshop, we arrived with some news. So we reworked this test infrastructure to be plugin based. So the TMT1 is one of the plugins, but now we support multiple other test infrastructure. So you can run your test on trigger and run tests on GitLab CI, GitHub Action, KernelCI. You can run tests also on testing farm, that is another Red Hat project. So it's our test infrastructure. And with this version, the last version that we are presenting today, you can also use Lava, the narrow test infrastructure, to trigger tests on Lava, or to trace back test result from Lava to BASIL. And you see that it's also possible to create a relationship between bugs and bug fixes that can be part of your traceability matrix. So few strengths of these tools is essentially it is able to generate an extended traceability matrix in SPDX format. And it comes with a web user interface developed on top of another Red Hat project that is Patternfly UI. It's a framework for developing UI that will pay a lot of attention to accessibility. And this tool comes also with an HTTP REST API. So any action that you perform on the web UI is possible to perform the same action with the command line, essentially connecting to the HTTP API. So any action can be automated. And also, it is possible to define user permission, because this tool is intended to be used by community. And you can specify for each software component who can do which things. Now, you can specify user permission with a high level of granularity. And also want to highlight that the goal of this tool is also to clarify gaps. That is sometimes one of the problems for upstream projects. Now, people sometimes have problem to understand how can start contributing to an upstream project. No? So the idea is to have a public instance of this tool for different projects and clarify gaps. The tool helps doing this thing in two different ways. One is that you can have pieces of your specification that doesn't have any relationship. So it's a clear gap. The other one is that this tool also use a percentage of completeness on each relationship. That is something that is supported in SPDX, but in SPDX is something like a Boolean value. We basically instead use let's say a percentage value. But so you with this value you can clarify that, for example, there is some remaining work on some piece of specification.
Can you put a request in to SPDX
Yeah.
to consider putting that in? Because I think that'll end up being useful for what is being looked at from fall as well.
Sure. Sure. Okay, and last thing I want to mention is that this tool keeps track of all the changes. And so we have in ELISA a public instance of this tool that is available at this website. You can join, create an account, and start playing with it, even if it's quite easy to deploy it on your machine. So where we left off at last workshop, we changed the test infrastructure to have a test infrastructure that is plugin based, as I described before, and we arrived at FOSDEM 25 with a rework of the SPDX export feature, so that now is based on SPDX Model 3, and it's also possible to export the traceability at each software component level. So before it was only possible at library level. So if you have thousands of components in your library, it was a big pain. So what's new? I'll try to be really quick. We developed, thanks to contribution that we had a deployment script that is a way to simplify, the deployment for the one that want to try it. So essentially, it comes with some options that allow you to specify the port on where you want to run your API, where you want to deploy your front end, the default admin password, so and a few other things that you can see just asking the help file of this script. So it will take care of building Podman containers, volumes, and to inject environment variables in your deployment. We also reworked the user permission configuration that now comes, so simplify a lot this effort. So it's also possible to copy the user permission definition across all the other software components for the one you are the owner. So you can copy, paste the user permission definition across thousands of software components with a bunch of clicks. And yeah, we also introduced the possibility now to configure a web server, an email server, sorry, to be able to notify users and to be able to reset user password.
Does it operate with single sign-on?
Not yet.
Not yet.
No, not yet. It is just a username and password. Yeah. Good point. So it's in the roadmap. Yeah. Let's see. Yeah. We extended also the software requirement imports because it was one of the questions that we got to post them. So how to migrate from a vendor tool to this tool. So it was possible already to import the requirement from SPDX Model 3 files generated by BASIL, but now it's also possible to use CSV, YAML, JSON spreadsheet, and SPDX Model 3 generated by StrictDoc that actually looks a bit different from the one that are generated by BASIL.
Oh, good.
That's
Excellent.
why.
Let's go figure that out.
Yeah. Yeah. So there is another feature, the test case import, that is kind of, let's say, new thing. So you can scan a remote repository that is implementing TMT, so that have this kind of file that abstract the test execution. So the scan feature will generate a JSON that you can use to import all the tests in BASIL, and then you can reuse across your software components. So we have test repository that are using TMT in GitLab.com for kernel. We have the same on Fedora project for multiple packages. So we will have a quick demo to see how this works. And then we extended the support of external test infrastructure to Lava. So just want to mention, because now it's good for understanding the process of the tool developing and the quality that we are trying to put into the tool. So when we introduced the user management, our testing was broken because to access the test, the features, we need to have some information about the users, no? Because we have the user permission, so each action is filtered by the user permission. So we had some black period where we have no testing into the CI, but that is no longer true because we re-enabled all the end-to-end testing that has been developed on Cypress. And we extended it to software requirement imports, test case imports, documents mapping, and other features. The current effort, there is a new contributor that is helping out with testing the REST API. That is a kind of 10,000 code lines project. And so we are writing specification and creating tests across of the specification as kind of new things. And the testing are still running now in the CI. And last thing was is that before this version 1.7, we had some API, some features that were developed on top of Chrome APIs, because in the browser you can select a piece of the document and the tool itself understands that you want to create a relationship on top of this. And now we rework these features React that is now using a widely used API. So there is no longer a restriction as far as we know. So you can use any kind of browsers. So let's try to have a quick demo. Let's see. It's visible. It's visible.
Little
So this
bigger.
is how the
little bit bigger.
Little bigger.
little bigger. Okay, let's try this way. So this is how the tools looks like. Now I'm logged in as the admin, but just because I created a bunch of software components with this user. So let me show quickly how the traceability looks like. So I use this is a simple example where I have just one test mapped against the specification. This is an endpoint of the REST API of BASIL, the specification of that endpoint, and we have a test mapped on top of it. So just to show the simple case, but you can see that you can specify creating the relationship, a percentage of completeness that in the tool is named coverage, but can be can generate mistake in quality engineering. But and you can have a hierarchy of work items, and the completeness is calculated in a waterfall model and reflected on the left side of the specification. So you have an understanding of where you are in the process. No? So from here you can see the history of these work items, run a test using the different plugins as we have, or you can navigate test results, and or you can also try to source external test result, navigating, for example, Lava. If you, let's see if we can see something. Okay, so how I'm doing this magic, there is essentially a file that you can use to configure your external test infrastructure. So is this one, where you can specify multiple test infrastructure configuration. Those are commented actually, but there is just one for Lava, but you can have multiple one. So you can specify your instance endpoint, your token that can be also nested under an environment variable. So if you want to be more restricted, and then you can also specify environment variable that you want to inject by default into the test environment. So that's one thing. Let me quickly show a more complex traceability, a bit more complex traceability, where we have a hierarchy of software requirements, and I have a test specification nested under a software requirement, and a test cases nested under a test specification. So you can see that when we specify a percentage that is less than 100%, we have here a gap highlighted, and that is propagated top level to arrive to the specification. So you can have this picture. Another thing is that BASIL comes with a different mapping view. So this view is focusing on requirements, but you can have different people working on different things. So you can, for example, having a team working on test specification that can just work on a different mapping view, and another team that is just taking care about test cases and can work on another mapping view. So let's try to have a look to the import features. So I can select a piece of the specification like this, and then I can say to the tool, assign a test case, for example. Okay. And then I can import from external sources. So I can ask to the tool to scan an external test repository like Fedora Project, RPMs, GC that can hold some tests for regression that we use in Fedora. You can specify the branch that you want, and you can request a scan. So in the meantime, the tool is scanning the test repository and is generating a JSON file. So you will see the files in your user file. So from the list, you will see a file like this, JSON .json file. So if you select it, you can load test cases. So you see I'm able to import in one shot all those test cases inside the tool and I can reuse them across all the software components, okay? And those are ready to run also because are written in TMT, that is the embedded test infrastructure. Let's see quickly also how we can import software requirements. So the same way, so you can just select test cases in the repository. There is a folder, there is examples, import requirements. There is a bunch of example files that you can open. So as an example, strict.pdx. So you can import the file, the requirements. Just selecting it, and then you will see it in the list of existing requirements, and you can reuse it across the software components now, because you can reuse work items across multiple software components, and also you can fork work items if you need to, for some reason, to diverge. So you can use the same work item across 100 software components. For some reason, you can, for just one other software component, you can diverge and make your changes. A quick look to the user permission definition. So for each software component, for the one you are the owner, or you have the owner permission, you can specify user permission. So you can see the list of all the users, and you can assign permission to each user. So there are some basic rules. So for example, now if you need to write, you need read permission, stuff like that. So the tool takes care of those things. And also you specify the permissions. Let's say you can confirm, and you can also ask the tool to clone it across all the other software components in one shot. So you can select everything and just confirm, and it will create the permissions. For the ones, yeah, we have 4 minutes. Yeah, no, don't want to go too long, sorry. Yeah, let me just see and show how we can run a test on Lava. This is a test case. Let me show the test detail. Is a test written in Lava test specification. Is a remote test. You can run tests from remote repositories. So you just need to specify the repository and the relative path of the test inside the repository. The work item itself comes with some other fields like the title, description, the status, because you can also manage the status of work items. So you can have approval life cycle. You can have, let's say, collaboration between people. And please.
Do you capture the version of the file that you're running? If you're running a particular tag or a particular char in that option, do you kind of capture that information in there?
Yeah, that's by default with TMT. TMT capture the test hash repository. Yeah. But
So I was just thinking for actually linking it to your requirement traceability.
Yeah.
If the file that you're referencing changes, do you detect that the fact that that file's been updated and
Yeah.
maybe the kind of the relationship might have been.
yeah, that thing is not yet. Let's say we don't have a field for the commit at the moment. The commit is generated, as I said, by TMT into the log, because it's cloning the repository and is checking the hash. So you have a reference for it, but it's kind of important things also for say continuous deployment, continuous compliance, stuff like that. So probably we will add it. There was already a discussion about it. Yeah, and yeah, thanks for the question. And so with those two information, the repository, the relative path, you can ask the tool to run it. So what you need is to specify some information. So you have to specify the URL and of the Lava instance. So I have a local Lava instance at this URL, as you can see. And you have to specify the API token that you need to interact with it, essentially. Another thing that you need with Lava is a Lava job file. We have a default Lava job file, but you can, that is used to test against Aquimo, but you can have any kind of job file. You can have your job file to run on different targets. No? When you create a configuration file, that configuration file can be reused across the application. So you don't have to specify it all the time. So we have a list of, we store a list of different test run configurations. So you can just select an historical one and press run on the view. And the result will show here in the result view like this. No? And from here, you can also, if you want to reuse the same configuration from here, you can just click rerun. It will start a new request with the identical setup. So, and this thing can be automated in from REST API. So you can list your requirements in a software component, and for each requirement, you can list your test cases. If anything so that you want, you can rerun the test and create the traceability. The traceability can be generated by this button, and it will look like this. So it's a JSON format in SPDX model 3. So 51. No, I'm done. So if you have any questions, let me know.
Really exciting to see how it's all emerging. Nice work, Luigi. Very nice work. Contributions to the QD are welcome.